converting mixed numbers into improper fractions, and vice versa. So first thing, let's see what mixed numbers are. They are a combination of a whole number and a fraction. And we could express these two as, so the whole number in diagrams. So we have 3 full wholes, 3 full units, pretending they're all the same size, but we still need another half. So I'll get another whole, but I will halve it, and I will shade only that half. So this is what 3 halves will look in diagrams. Now, if we're looking at a fraction like 7 halves, that's what we call an improper fraction, because we know that we have more than a whole in here. Because how many times does 2 go into 7? Well, 2 go at least 3 times and a bit more. So this is why it's called an improper fraction. The top number is greater than the bottom number. So how would I express 7 halves in diagrams? Well, I still have to start with wholes every time. Let's see how many wholes we'll need. But they have to be halved. So I'll halve them all. So let's see how many wholes I have here. I have so far 2 wholes, but I have how many halves? 2 halves, 3, 4. Of course, I need more wholes to make up these halves. So let's halve this whole as well. Now 5, 6, and I still need another half to say 7 halves. Oops. So here we are. 7 halves, 7 pink halves, and here on the left hand side 3 blue wholes and a half. So our work now is to convert them without drawing diagrams, but let's see where the link is. Basically, if I halved all the blue wholes, we would have exactly the same diagrams. So let's see how we can do to check here. Looking at the blue ones, we have 2 halves, 2 halves, 2 halves, and 1 half. So this are my 7 halves, equivalent to that one over there. And doing the opposite thing, looking at the pink ones, well, these 2 halves make up a whole, 1 whole. These other 2 halves, another whole. 2 more halves, another whole, and here we still have a half. So look at that. That's our 3 wholes and a half. So let's try to look at the mixed number and checking how we are going to convert it in a quick way without drawing the diagrams. We should know that in 3 wholes there are always 6 halves, but the quick way would be starting from the bottom and going in the clockwise direction. We're going to multiply here. So 2 times 3 will give us 6. That means there are 6 halves in a whole. But there is 1 half left. So, and then we're going to add that one that is missing, plus 1, which gives us the 7. And we are talking in halves every time, so 7 halves. So just recapping, the 3 and a half, we look at the bottom number to start with and go anti-clockwise that way. So first thing we do is we multiply the bottom number by the whole part, 6, and then we add to the top number, 7. The bottom number here, the halves, still stay the same. Let's look now, starting from the improper fraction, how we rewrite this as a mixed number. Well, the idea is the fraction line is like divided. So we could have been looking at this as 7 divided by 2. The other way of asking that is how many 2's go into 7. Or like here, how many 2's go into 7? And some people might even do it like that, 7 divided by 2. How many 2's go into 7? We know it's 3 full 2's. So let's come back here. 7 halves equals 3, because 3 times 2 is 6. And let's do that here. 3 times 2 is 6, and the remainder is 1. That remainder is the number we're going to use to create our little fraction here. 1 half. The number on the bottom still is 2. We're still talking halves. So 7 halves is the same as 3 wholes and a half.